A block of mass 12 kilograms is at rest on a plane which is inclined at 25 degrees to the horizontal. A light, inextensible rope is attached to the block and passes over a small pulley and supports a mass of m kilograms which hangs freely. The part of the rope between the block and the pulley is parallel to the line of the slope of the plane. A friction force of 18 Newton opposes the motion of the block. A. Calculate the value of m when the block slides up the plane at a constant speed and find the tension in the rope. And B. Calculate the acceleration of the system when m is equal to 16 kilograms and find the tension in the rope in this case. So what we've got here, we've got a 12 kilogram block attached by a light, inextensible rope passing over a smooth pulley, and we've got a weight here, our mass here attached at m kilograms. Okay, so we've got to find the tension in the rope and when the block is sliding up the plane with a constant speed. So the first step would be to draw a force diagram. To take some time, you need a large clear diagram. So the forces acting on the 12 kilogram block will be the weight, which is 12 g newtons acting downwards. We will have a normal reaction to the block acting with the plane. We have an 80 Newton frictional force because as the block is going to move up the plane, the friction opposes the motion. And we have a tension in the rope. Now the same tension in the rope will be here as well. And we have the weight of the block, mg newtons acting down. We've got to calculate the value of m. It's moving with v meters per second, so there's no acceleration, so we won't be using Newton's second law. So moving at a constant speed, we note that. So if we now resolve along the plane for the 12 kilogram mass, t, right, minus 12g sine 25. So remember what you do, you draw that one down and that one down because that's perpendicular to the plane. So this one here will be mg sine of 25, so 12g sine 25, also acting against the tension, minus the frictional force, and because it's moving at a constant velocity, that will be equal to 0. So from that we can say that t is going to be equal to 12g sine 25 plus 80, and then we can work that out on our calculator, get 129.69 newtons, which is 130 newtons correct to 3 significant figures. Now resolving for the vertically for the m kilogram mass. Okay, so it's moving this way, so we'll take downwards as being positive, so we'll say mg minus t will be equal to 0 because it's moving at a constant velocity. So mg will be equal to t, and therefore m will be t over g. So substituting this value in here, don't substitute 130, you need to take one which has not been rounded off. So substituting in 12g sine 25 plus 80, or use answer on your calculator, divided by g, which is 9.8, and that will give the mass being equal to 13.23 kilograms, which gives you 13.2 kilograms. Okay, so now considering the second case where we have a mass now of 16 kilograms, so this will be 16g newtons, and we now have an acceleration, so we're now using Newton's second law. So doing a similar sort of thing, so using Newton's second law, because we've got an acceleration now, for the 12 kilogram mass. So again, we're going to have t minus 12g sine 25 is minus 80 is equal to 12a, using Newton's second law. Now we'll call that equation 1 because we've got two unknowns, so we'll need to find a second equation. Now for the 16 kilogram mass, so m is now 16, resolving vertically, and we're taking downwards as positive, we're going to have 16g minus t is equal to 16a. We've got equation 1, equation 2. Now the procedure is to add the two equations. So if we add the two equations, the t minus t's will cancel out. So you're going to have plus 16g minus 12g sine 25 minus 80 is equal to 12 plus 16 makes 28a. And therefore A you will get by doing 16g minus 12g sine 25 minus 80 divided by 28, and that will give an acceleration of 0.9678 meters per second squared. So that will give me 0.968 meters per second squared as the acceleration. Substituting into 2, 16g minus t is equal to 16a, we're going to have 16g minus t is equal to 16 times the value I've just calculated. Don't use one which has been rounded off. So t will be 16g minus 16 times 0.9678, which was the acceleration, and therefore the tension will be 141.31 newtons. Correct to free figures, that's 141 newtons. So this has been a video showing you how to calculate forces when you have either a constant velocity or an acceleration. I hope you've understood, and I thank you very much for watching.